Right, so we'll take one last example which says x of find the, or I'll say evaluate the following convolution. Okay, so evaluate, it's little bit laborious. Okay, so evaluate 2, I'll write down below, 2 cos of 997t multiplied with sine phi t divided by pi t. Okay, and this fellow is convolved with 2 cos of 1000 t multiplied with sine 4t divided by pi t. Okay, so we want to evaluate the convolution of these two signals. Okay, definitely it involves few properties, we will see one by one. So this first signal, let us call that to be x of t, and second signal, let us call that to be h of t, and whatever we get at the output, let us call that to be y of t. Okay, so next, this sine t divided sine phi t by pi t, let us call that as x1 of t, and sine 4t by pi t, let us call that to be h1 of t. Okay, yes, so just to make our life simple, we'll write down. So let us start with x1 of t. Okay, so x1 of t is equal to sine phi t divided by pi t. So this fellow will have what as Fourier transform? This fellow will have a rectangular function from where to where? From -5 to +5 with amplitude 1 as the Fourier transform. Now what is x of t here? X of t is nothing but, okay, 2 times cos 997t multiplied with x1 of t. So definitely, what is this property? This is nothing but the modulation property. So what is that you have to do? You have to shift the Fourier transform. This is our x1 of j omega to the right and left by how many units? 997 units. So if you shift the Fourier transform to the left and right by 997 units. So how does the plot look? The plot looks like this. So x1 of j omega is shifted to the right and left by how many units? 997 units. So if you shift by 997 units, this fellow would be 992. This fellow would be 1000. Correct, that fellow would be 9009. This fellow will shift to 992 and this fellow will shift to 1002. Amplitude would be 1. Why? Because the time domain signal is multiplied with 2 here. So this is minus 1002, this is minus 992. Okay, so this is our x of j omega. Next, so let us look at h1 of t and then write what is h1 of j omega. Okay, so what is h1 of t? h1 of t is given by sine 4t divided by pi t. So clearly we know this fellow's Fourier transform, which is a rectangular function from -4 to +4 with amplitude 1. Okay, but what is our h of t here? Our h of t is 2 cos of 1000t multiplied with our h1 of t. Okay, so what will be the, this is our h1 of j omega. Again, what is happening? Our h1 of t is multiplied with cos 1000t, means what? Again you have to shift the Fourier transform to the left and right by how many units? You have to shift the Fourier transform to the left and right by 1000 units. So if you shift to the left and right by 1000 units, so this fellow will go to where here? 1000 units. If you shift to the left and right by 1000 units, so this fellow will go to 996. Okay, so 996 to 1004, correct? So this is 996 and this fellow will go to 1004. So here also this fellow would be from -1004 to 996. Okay, so -1004 to 996. So this would be our h of j omega. Okay, right. Now what is the final question? Final question is we have to find y of t, which is equal to x of t convolved with h of t. Correct? Question is we have to convolve this x of t with h of t. So what will happen in frequency domain? We get y of j omega, which is equal to x of j omega multiplied with h of j omega. Means you have to multiply these two signals, correct? These two Fourier transforms, x of j omega multiplied with h of j omega. So if you look at the plots little bit carefully, the right hand side product exists from where to where? This rectangle exists from 992 to 1002. This rectangle exists from 996 to 1004. After multiplication, what happens here? The product exists from 996 to 1002. Okay. So let us plot our y of j omega. Okay. So y of j omega will look like this. Okay, so final plot will look from where to where? You will get a rectangle from 996 to 1002, and similarly in negative side this rectangle exists from where to where? Minus 1002 to minus 992. So this rectangle exists from minus 1004 to 996. So overall product exists from where to where? Minus 1002 to minus, one second. Okay, so minus 1002 to 996. Okay, sorry for that. I'll draw properly. So you'll get minus 1002 to 996. So this is our y of j omega. Okay, so this would be 996 and this is 1002. So this is minus 996 minus 1002. What happens to the amplitude? It remains same. Okay, so but if you look at y of j omega, again what is this? This is a rectangular function of width how much? Of width 6, shifted to the left and right by how many units? Shifted to the left and right by how many units? I'll write down that. Okay, let me call that to be y1 of j omega. Okay, this is our y1 of j omega, which is a rectangle. Width is 6 and hence we can take the actual rectangle from minus 3 to plus 3. So let me call this as y1 of j omega. Correct. So how is this looking at? We want y of t whose Fourier transform is y of j omega, which is given like this. Okay, but if you look at this little bit carefully, what is that you see? You see that our y of j omega is nothing but y1 of j omega shifted to the left and right by how many units? 999 units. Okay, so we see that y of j omega is equal to how much? Y1 of j omega plus 999, correct, plus y1 of j omega minus 999. Okay, so you shift this to the right by 999 units, you get this rectangle. Shift this to the left by 999 units, you get this rectangle. So you have amplitude to be 1, that we will see. So what is the corresponding signal which will have this rectangle as a Fourier transform? Let us call that to be y1 of t, which is equal to sine wt, which is sine 3t divided by pi t. Okay, we got y1 of t, but we don't want that. We want what? We want y of t. So y of t is nothing but, so how do you get the shifting in frequency domain? You have to multiply with cos omega t. So what is omega naught? It is 999. So finally you get our y of t as what? y1 of t multiplied with 2 cos of 999 t. Correct. So that is why if you have amplitude to be 1, so definitely should multiply with 2 here. So what should be the final answer? You will get 2 times sine 3t divided by pi t multiplied with cos 999 t. Okay, so in that way we can, if you look at the problem, then you will understand the gravity. So what is the question here? We have to find the convolution of these two signals. If you do that in time domain, it is not at all easy, and it is near to impossible for us. Okay, mathematicians they can do, but as far as engineering students are concerned, it would be tough. Okay, but we are little bit smart, and hence we will take the help of the Fourier transform, where convolution in time domain corresponds to multiplication in frequency domain. Okay, so the convolution of these two signals boils down to what? Just multiplication of the corresponding Fourier transform. So you should be a little bit careful in evaluating the multiplication. Okay, so and finally we get this as the product, and we know that the product is looking like what? Rectangle shifting to the left and right. So that again corresponds to what property? Modulation property, and hence you get final answer to be how much? 2 sine 3t by pi t multiplied with cos 999t. So let us summarize what we have got. Okay, same problem. We just write down the final answer. So what did we get? So we 2 cos 997t multiplied with sine phi t by pi t. This fellow convolved with 2 cos 1000t multiplied with sine 4t divided by pi t. Correct? So after convolution, this answer we got to be how much? 2 cos 999t multiplied with sine 3t divided by pi t. So in that way we can take the help of convolution in time domain property even to find the convolution of this kind of complex signals. Okay.